Over 300 million chicken fingers are sold every single year by one fast-growing chicken brand. Now imagine this. Every single crispy strip you dip into that signature sauce began its journey inside a massive industrial system built for speed, precision, and zero mistakes. But what really happens before it lands in that red basket? Most people think it's simple. Chicken, batter, fry, done. But inside a real food factory, nothing is that basic. Every second is measured. Every temperature is monitored. Every piece must look, taste, and feel exactly the same. If you're curious about how everyday favorites are engineered at massive scale, you're in the right place. This is Infusions and Elements, where we uncover the hidden science behind factory processes, mass production, and industrial food secrets. So how are Raising Cane-style chicken fingers made in a factory setting? Let's step inside the process most people never get to see. And if you enjoy discovering what really happens behind factory walls, make sure you subscribe, because once you see how things are made, you can't unsee it. The beginning of raw chicken processing. It all starts with fresh chicken breast meat, not random cuts, not leftovers, whole muscle breast fillets. The chicken arrives chilled under strict temperature control. If it rises even slightly above safe levels, it gets rejected. Before anything else, quality teams test random samples. They check texture, color, moisture levels, food safety compliance. Because once production begins, thousands of pounds move every hour. One small issue could multiply instantly. Next comes trimming and portioning. Large automated cutting machines slice the chicken breasts into long uniform strips. Uniformity matters more than you think. If one strip is thicker, it cooks slower. If another is thinner, it dries out. Consistency is everything. Some industrial portioning systems can cut over 6,000 pounds per hour. That's heavier than a small car. Every single hour, where flavor locks in. Now the raw strips move into massive stainless steel tumblers. These drums rotate slowly while seasoning blends are added. Salt, spices, functional ingredients that improve moisture retention. This isn't just flavor, this is food science. As the drum spins, the strips gently tumble over each other. The seasoning distributes evenly. In some facilities, vacuum pressure is applied inside the tumbler. This helps the marinade penetrate deeper into the muscle fibers instead of just coating the surface. Imagine thousands of strips rotating in a giant steel chamber, absorbing flavor evenly from every angle. After tumbling, the chicken rests under refrigeration. This resting phase allows the seasoning to bind properly. Skip this step, and the texture changes. Factories don't skip steps, engineering the crunch. Now comes the transformation. The strips enter the breading line. First stop, pre-dust. A thin layer of seasoned flour lightly coats the surface. This acts like glue for the next stage. Then comes the batter bath. The strips travel through a liquid mixture made from flour, starches, and spices. The thickness of this batter is constantly monitored. If humidity changes in the room, the batter formula adjusts. If flow rate shifts, sensors detect it. Factories correct problems before humans even notice them. Next is the final breading layer. Dry seasoned flour cascades down like a curtain. The battered strips pass underneath. This creates those rough, craggy ridges you see on the surface. Those irregular shapes aren't accidents. They create more surface area. More surface area means more crunch. Some breading lines move at over 150 feet per minute, faster than a professional athlete sprinting down a track, and yet every strip gets coated evenly. The frying tunnel, where science meets heat. Now the coated strips move toward the heart of the operation, the continuous industrial fryer. This is not a small kitchen vat. It's a stainless steel tunnel filled with hot circulating oil. The temperature stays tightly controlled around 170 to 180 degrees Celsius. Too low and the coating absorbs oil. Too high and the outside burns before the inside cooks. The strips enter on a conveyor mesh belt and float through the oil. Inside the coating, something incredible happens. Moisture from the chicken turns into steam. That steam pushes outward. It forms the crispy shell. Meanwhile, inside the meat, proteins firm up and lock in juices. This balance, crispy outside, tender inside, is pure thermodynamics. The fryer continuously filters oil to remove crumbs. Oil quality sensors monitor breakdown levels, because degraded oil changes flavor and color. Some industrial fryers can process thousands of pounds per hour without stopping. All synchronized, all controlled. If you're starting to realize how much engineering hides behind something so simple, stay with me, because factory production gets even more fascinating the deeper we go. Stabilization and cooling. Once the strips exit the fryer, they're perfectly golden, crisp on the outside, and steaming hot from the intense heat of the oil. But even at this stage, the process isn't complete. Timing still matters. First, excess oil needs to be removed. As the chicken moves along the conveyor, powerful but carefully controlled air systems blow across the surface. This step reduces surface oil without disturbing the delicate crust that just formed. Then comes rapid stabilization. Cooking doesn't instantly stop the moment the strips leave the fryer. Internal heat continues working for a short time. If that heat isn't controlled, the texture can change, and the inside may overcook. To prevent this, the strips move into a precisely managed cooling zone designed to stabilize temperature quickly. In facilities producing for distribution, blast freezing is often used. These systems drop the temperature extremely fast. Rapid freezing forms tiny ice crystals instead of large ones. Large crystals can damage muscle fibers, but smaller crystals protect texture. That's why properly frozen chicken fingers can stay tender and juicy even after reheating. Inspection and quality control. Despite the high level of automation inside modern food factories, human inspection still plays a critical role. Machines can measure speed and temperature, but trained eyes notice details algorithms might miss. Quality control teams stand along the line to visually inspect each batch for consistent color, proper coating coverage, and overall appearance. The golden shade must be uniform. The crust must fully cover the surface. Anything that looks uneven is removed immediately. At regular intervals, random strips are taken off the line and cut open. Technicians check internal temperature to confirm it meets strict food safety standards. Undercooked or overcooked pieces are never allowed to pass. Advanced color sensors also scan products as they move along the conveyor. These systems compare each strip to preset digital standards. If a piece appears too dark or too pale, it's automatically rejected. Every batch is logged, coded, and fully traceable. If a problem ever occurs, factories can pinpoint the exact production time within minutes. Would you feel more confident knowing this level of inspection happens behind the scenes? Packaging and cold chain logistics. Now the finished strips move toward the final stage inside the factory. Packaging. Speed increases again, but precision never drops. High-speed weighing systems measure exact portions automatically. If a pack is slightly too heavy, the system adjusts. If it's too light, it corrects instantly. Nothing leaves the line without meeting strict weight standards. The chicken strips are then sealed inside protective packaging designed to lock in freshness and prevent contamination. Each pack receives a production code that identifies the exact batch, date, and processing line. This ensures full traceability if needed. After sealing, cartons are stacked in organized layers, tightly wrapped and prepared for shipment. But the process doesn't end at the loading dock. Refrigerated trucks maintain controlled temperatures during transport. Sensors continuously monitor conditions inside the trailer. If temperatures shift outside the safe range, alerts are triggered immediately. From factory to distribution center to restaurant kitchen, the cold chain must remain unbroken. Because consistency isn't just created inside the factory, it must survive the entire journey. Final preparation at the restaurant. Even at the restaurant level, precision continues. Oil temperature is monitored daily. Fry timers control each batch. Oil filtration keeps quality stable. The goal is simple: make every single order taste exactly like the last one. Consistency builds trust. From raw chicken arrival to final packaging, the entire process can take only a few hours. But inside those hours, thousands of micro decisions happen. Precision cutting, vacuum marination, layered breading, high-speed frying, rapid stabilization, strict inspection, cold chain logistics, all working together so that when you bite into one crispy strip, it feels effortless. But now you know. Behind that crunch is steam pressure physics. Behind that juiciness is protein science. Behind that golden color is monitored oil chemistry. Factories like these operate day and night, millions of pieces per year, perfectly synchronized. And most people never think about it. Until now. If you want to uncover more hidden factory secrets and see how everyday favorites are engineered at massive scale, subscribe now and stay connected with infusions and elements. Because once you see how things are really made, you'll never look at them the same way again.